Hi guys, today we're doing projectile motion if you're doing the 3-net HSC mathematics. This is all about motion such as a ball being thrown or hit or an object just being catapulted. So basically we start off with a diagram like this where you show some sort of object being launched and that is your motion. Alright, so that's the path that the trajectory takes. Now, so we're given normally an initial velocity. Okay, we'll denote that as v. We're given an angle of projection, theta. Okay, and we're given an origin where it starts from. In this case, we can start at, let's say this is 0, 0, so ground level. Okay. In other questions, you might be on the top of a cliff or something. In that case, here is your 0, 0, and you've got to match whatever that is. Whatever h that is, okay? Alright, so we're going to use the generic example here where we are starting from 0, 0. Now from here we can get initial conditions which are pretty much, you need this initial conditions in every question, okay? That is, what happens at t equals 0. And from here, if you draw this part of the diagram out, you will get your v, you've got your y velocity, and you've got your x velocity. And using your year 9, SOHCAHTOA trigonometry, you can get from here that your initial velocity is your x dot is v cos theta, and your y dot is your v sine theta. So, initial conditions you would need to write up. And most questions will ask you how far does it travel, what's the greatest height attained, or find the angle if it hits some sort of point. And to do these, we actually need to derive equations of motion. So, to derive equations of motion, all we know for the x velocity, so not the x velocity, sorry, the x acceleration, horizontal acceleration. You're thinking about a ball that goes through the air. We're not really thinking of air resistance for mathematical purposes, so you can ignore all that. So in other words, your x acceleration, your horizontal acceleration, starts off at 0. There's no horizontal force acting on your object flying through the air. And from here, using your basic motion knowledge, you would know that to get to the x velocity, you would need to then integrate that with respect to t. So x velocity would equal the integral of x dot dot dt. Okay, and that is just the integral of 0 dt, which you get at is equal to c. And then you use your initial conditions. Alright, so x dot equals c. How do I find my constant? Well, I know for a fact that at t equals 0, your x velocity, your horizontal velocity, is v cos theta. So because there's nothing else there, therefore you get your x velocity formula, which is x dot equals v cos theta. Cool. Now the next part you need is the x position formula. So where is x? Where is the ball? Where is the ball horizontally? Alright, on the horizontal x-axis. Okay, so just keep in mind that is the y-axis and that is still the x-axis. Alright, so to get that is just once again integrating your x velocity in respect to t. And so that equals the integral of v cos theta dt, which will give you v cos theta t plus c. Okay, so that's just like integrating a constant. Because there is no t in this formula, we don't have to go through the hectic, trigonometric integrals. Not that it is hectic anyway, but yeah, it's much easier than that. We are integrating with respect to t, keep that in mind. Using our initial conditions, don't forget, we've got your x dot as v cos theta, you've got your y dot as v sine theta. You also have your x equals 0, and your y equal to 0. That's when you're starting off at the origin, which we've assumed here. Questions, as I said, might ask you to start off some sort of elevated point, in which case that value should change. I haven't yet seen a question where they've, moved your starting position horizontally in any way. So you could assume for most questions that x would start at 0. Integrating that, now you've got that constant part that you need to fill in. So using those initial conditions, once again, t equals 0, x equals 0, put those in. 0 equals 0 plus c. So you get, using initial conditions, c equals 0, therefore, I'll write that in. So t equals 0, x equals 0, so you get your c equals 0. Therefore, you end up with x equals to v cos theta t. Okay, right? It's written as vt cos theta normally. Because it looks like cos of theta t, so I'm just gonna write it like this: vt, right, cos theta. Okay. All right. So moving on. Let me just change that to, well, doesn't matter. Moving on, you've got now vertically. So vertically, you've got your y dot dot. Now, in terms of vertical acceleration, you do have you do have a vertical force acting on anything that flies through the air, which for those of you who do physics, you would know, or everyone should know, that there is a force called gravity in our world which keeps us on this ground. So now, normally you're going to be using, minus g, alright? Now, this minus g, questions will tell you it could be, g equals, 9.8 ms per second squared, or 10 ms per second squared. For my example, I will just start off with a generic minus g for gravity. Right, so we're going on to do the same for y. And your y dot is equal to the integral of minus g dt, which gives you minus gt plus c. And you know that initially at t equals 0, y dot equals v sine theta. So that gives you c equals, if you sub that onto the above, you will get v sine theta equals 0 plus c, so c equals v sine theta. And that's how you end up with, therefore, the y velocity function is equal to minus gt plus v sine theta. And then next, to get the y position formula, it's just simple y equals the integral of minus gt plus b sine theta with respect to t again. And you'll get minus gt squared on 2 plus vt sine theta plus c. Now here, because at t equals 0, you got your y equals 0, that'll give you c equals 0. And you end up with, therefore, y equals minus gt squared on 2 plus vt sine theta. And that is your y equation.